we're going to solve free fall problems. Now, one thing that you might notice, and I like to point out ahead of time, is that these are really absolutely no different than plain old, I've lost my, good thing it's on a string. These are no different than objects being accelerated horizontally. They are exactly the same, except what?
And it's always 9.8.
And it's always 9.8. In fact, one could argue that it's actually easier because you know the acceleration is always 9.8. Okay? So let's begin. There are the formulas you're going to need. Basically, weight force is mg. You need to know that g, or acceleration, is 9.8 meters per second squared. And then the formulas that we had from the start of the year, right? V bar equals delta V over delta T. Delta V is VF minus VI. V bar equals VF plus VF over 2. And A equals delta V over delta T. And you have them all right on your sheet there, right? All nicely laid out for you. So let's begin. The Demon Drop is a ride at an amusement park. You've all probably been to an amusement park at some point in your life. Of course, being the nerd that I am, when I go to amusement parks, I do this sort of thing, and I watch it and time its free fall and try to figure out how high it is. And I honestly do that. I admit it freely. My wife usually stands at least 10 yards away while I do that. Yeah. Okay, so we watch it, we time its free fall at 1.5 seconds. How fast is it going when it reaches the bottom? Okay, so what do we need to know out of all this? Well, we've got the time, and so we've got t equals 1.5, and we're looking for how fast it's going when it reaches the bottom. Could we call that the final velocity? I think so. Josh, is it? How's the? I moved the device back there. How's the loudness? Is it okay?
Yeah, it's really annoying.
It's kind of annoying. Is it too loud?
It's cutting out.
Oh, really? What if I stand up? Is that better now? So I can't sit. Okay, I'm gonna have to get it mounted. Hey, you know what? Can you just get up and just put it on the top of the shelving unit there? Let's try that. It's probably because you're in the way. Yeah. Let me know if it keeps cutting out. Okay. Because this is one of those ones where it has to see it. It has to be a direct line. Okay. Now, there's a couple things in this question that are not explicitly stated in the question.
Where does it say the bottom?
How fast is it going when it reaches the bottom?
How do we know? So VF is at 7.
No, that's a question mark. Sorry.
Oh, well there. Well, that makes sense.
I guess that's why there's a dot in the game.
Question mark.
What's the
Sorry
number?
about that. There's two things that are implied here. I'll give you the first one. The acceleration is minus 9.8, and what's the first one that's
So
implied?
acceleration is always minus 9.8?
Yep. What's the other thing that's not stated, but you have to recognize? Anybody?
Starts at 0?
Yes, the VI is 0.
VF is always 0.
Okay? Those two things you have to be careful of. They tend to not be stated, they tend to be implied. Yeah.
Isn't VI like...
Initial velocity.
Yeah, I know what it is.
Oh. What are you asking then?
It's always 0 unless stated, right?
Yeah, generally. That's a pretty good way of, yeah. I wouldn't say always, but
No, unless.
one of those 99.9% of the time, yeah.
They say it's...
Yeah, really. Right. You're right. Okay, so we're trying to find VF. So I'm going to start with A equals delta V over delta T. Minus 9.8 is equal to?
Question mark over 2.
Delta V over time is 1.5, and let's solve that. So multiply that out, and you should get minus 14.7 meters per second. It is negative because the velocity changes. Why does it become negative? I'm going to write this step just for the sake of completeness, and then I'll discuss it. Okay. For the sake of completeness, you would say the change of velocity is minus 14.7, and then delta V equals VF minus VI, and so on. You'd come up with this, right? Do you absolutely need to write down that step in a solution on a test?
Why not?
No.
There's a little,
You can, by all means, if it helps you, if you like it, you go right ahead. I'm not going to judge you. I got no problem with it. I'm just saying that there are some of you that I know can do this in your head, right?
I can't, honestly.
Whatever makes it easier for you. I really don't care. Okay? If you just want to write VF equals minus 14.7, that's fine. If you just want to do the next step, or even, and even in this case, if you just sort of made that your final answer, I'd be okay with that. But you got to realize that this is only true if one thing was true. What is that? The VI is 0, right? If it's not, if you get into that habit, you just got to be aware that there are times when it's not equal to 0, so watch out. Okay, how about how high is the ride? So we're solving for D, right? We're solving for D displacement, question mark. The formula with D in it is
D equals D over T.
V bar equals D over T. Do we have V bar yet? We do not. So with your eraser, you're going to erase that and write it over there. And in practice, in enough time, you will realize that you shouldn't have wrote it down first. And you actually have to find the average, right? Should that be negative 14.7? Yeah, likely. Do you see how this is kind of like a do-over with some of those kinematics questions we did back? Right? You're really getting another chance. That is the one that goes up here. So how high is the demon drop?
Going too fast.
Am I going too fast?
Way too fast.
Okay, I'll stop. I'll stop. Okay, so I got an answer of minus 11 meters. What is that? Really, the D here, the D stands for displacement, right? So really, the height is what? Yeah, technically, the height is 11.03 meters. How scary is this ride?
Wait, why is it
Well, because this is a displacement, it drops minus 11, right? Like it.
the height's the opposite?
No, well, yeah. Height is usually measured vertically up,
Oh, it's
right?
like-
Positive.
0, height,
Yeah,
displacement.
I guess. It's because it's here, right? This is minus 11, but the height is usually measured up, right? So it's only 11 meters tall. Maybe it's not so scary.
Well, that's really high.
Okay. Let's do the tennis ball one here. Tennis ball is thrown upward with an initial velocity of plus 22.5. There it is right there, Nate, right?
Where? What?
Initial velocity, like you said, it's a 0 unless specifically stated.
Look at that.
It's caught at the same distance above the ground from which it was thrown. So what I mean is that here's the ground, and here's the stick figure that throws it up, and they catch it at the same height here, right? So that really implies that the displacement is 0. What would you have to do if he let it hit the ground?
Negative.
Yeah, like this would be like -1 or something around, right? That's how you would do that? That's actually a problem from grade 12 that we would do. But it's just that little extra step. So here, the displacement is 0.
I'm getting pointers.
How high does the ball rise? So we're looking for height. We're actually looking for the displacement up. And Nate, how long does the ball remain in the air? We're solving for time. What do we know? VI is plus 22.5.
You know, that's all these holes.
Acceleration is negative 9.8.
Always.
Okay, here's another one of those implied situations that isn't specifically stated. Ball goes up. How high does the ball rise? So at that point, right there, what's the VF? 0. Is that explicitly stated? No, but the velocity at that peak, at that very height, would be equal to 0. Would you agree?
Why?
Right? And some people don't see that. They don't get that. Or they haven't had enough practice with that. So just be aware. How high does the ball rise? Okay, so what, how am I going to do this? Any ideas?
No,
First we'll look for the V bar.
Find what?
The V bar.
Find the V bar. Okay.
Oh wait, no, because we don't even have time there.
I don't have time, do I?
Then we'll look for delta V.
I don't have V bar and I don't have time. Which one do I need first?
First we need time, so we can only do delta V because A equals...
Do I need the time?
Yeah. Yes, we do.
Well, I do, because in V bar equals D over T, right? I'm looking for this D here. I'm needing time. Could I get this one? I can find the average.
yeah, you go,
So it doesn't matter what order I do them in.
Yeah, because just 1 by 2, no.
Yeah, exactly.
Okay. 1 by 2.
Let's do that first then, Nate. VI plus, oh, I should write V bar equals, right? I apologize for the messiness there. So 22.5 plus 0 over 2, 11.25 meters per second. That's our average. I need the time too, don't I? How am I going to get time? It's this one, right? Now here's a situation. Do I technically know delta V? No. Can you do it in your head?
Yeah.
You can, because one end of that thing is 0, right? So if it goes from 22.5 to 0, what is the delta V?
Negative 22.
Minus 22.5.
What? Hold
If you
on.
don't like that, then do this. Do this then if you want.
Okay, got it. I feel it. VF 0.
Right? That's what we just did in our head.
I don't like VF 0. I don't know how.
Get over it, man.
I just don't know how.
Minus 22.5. Now what's my acceleration? Minus 9.8. Solve for t. So t is minus 22.5 divided by minus 9.8.
Oh wait. Okay.
2.3. Okay, so we got our time. V bar is equal to 11.25. We're solving for D. Time is 2.3. Okay, Nate, just because he's here doesn't mean you have to, you know. The displacement is 25.8 meters. How much do you think something like that would be worth?
Million marks.
No, like 3.
Yeah, 3 bar.
What?
Well, there's this step. There's do you think I need to give you a mark for that step?
Yeah.
Well, then if I'm giving you a mark for it, then you gotta like show me something. You can't just go from there to there.
Yeah.
I say 3.
3.
3. How long does the ball remain in the air? This is part B. I'm going to put that down here and I'm going to label it B. Really?
Is this for a continuation from another day? Because those numbers look familiar.
No, we're just doing some sample problems here, Lucas.
There was like one. There was one.
Mitch, so on which question we're on there? I think it's question 2, isn't it? On that sheet that I just handed you, Lucas. Part B, how long does the ball remain in the air? Well, it went up and it took 2.3 seconds. So what's the total time? Yeah, it's just 2.3 times 2, isn't it? Up and down.
25.8 for.
I took 2.3 times 11.25.
Oh, sorry.
Okay, someone's phone's going off.
I have to draw that arrow, Mr. Bennett.
Hey?
The arrow from like the left side.
Okay.
No, I'm saying.
It's charging over there? Okay, just leave it. It's good. It's good.
I don't want to kill the 41.
Don't take a charging phone in class.
Hey?
Don't take a charging phone before the end of class.
I don't want, I really, you know what, you guys, teachers do not want to take phones away. It is a pain in the
I
rear.
see the smile.
Okay. I'm going to warn you, this is a hard question.
Hand is Wonderland.
Yeah. How much room do you have?
Not a lot.
Right small.
Oh my god.
This is a hard question. Okay? Yeah, sharpen your pencil, sharpen your mind, sharpen whatever you need sharp for this question.
My knowledge.
Do you remember? This is true. Canada's Wonderland does have a drop ride. It is 230 feet tall.
To the skyscraper. Do we change it to meters or what?
We're going to do that, yeah. I actually was there. I actually stood there.
Oh, you measured it?
I actually measured it the time, and I figured out how high it was, and then I went home and Googled it, and I was really close.
How could you try it?
Because I'm afraid of heights, man.
Oh my
When
god.
you're in Canada,
And my wife says, I can't believe you're doing that.
Physics.
So
I'm
that,
such a
They
nerd.
don't ride them.
Okay, have you taken in math class yet things like this?
Yes, it sucks.
Have you taken those yet?
Yeah.
How many hands up? I need to see. How many people have seen that where they call it systems
Oh,
of equations?
well, something like that.
Yeah, kinda. Okay, so if you haven't taken, I think it's still in grade 11. This is a prelude to that. In that system of equations, you have two graphs like this, and you have to find the point of intersection, right? Remember that kind of stuff? Okay, now I'm seeing a few more people recognize it. This is an application of that. This is the reason why you have to learn that in math. Okay? Hang with me here. Stay with me. Okay. First of all, Gage is absolutely right. Let's take that 230 feet and convert to meters, and I'm just going to tell you it's 70.1. It has absolutely no bearing on the question. I could have just given it to you. I should probably just do that next time. 70 meters. Okay? I don't expect you to work in feet. How fast are you going when you reach the bottom, and how long does it take to reach the bottom, assuming free fall?
I'll give it that again.
Don't worry about it. I divided by some magic number. Seriously, don't worry
Now
about
I get number the next time.
it. You won't. I will give it to you in meters.
Okay. Well,
Okay.
more in general though. For these things.
I'll look it up, man.
Oh my gosh.
Your phone will do it. Is the initial velocity 0? Yes. We are solving for VF, unknown. Our acceleration is minus 9.8.
Alright, got it.
Now, what's different about this one from example 1?
No.
In example 1, I gave you the time. I didn't give you time here. In fact, I asked you to find time. So you're given one less thing. What was the first step back in example 1? A equals delta t over delta t, right?
Oh,
Okay, so is that going to have to be first step here?
no, don't be.
Yeah. A equals, and again, write small, you guys, delta v over delta t. Minus 9.8 is equal to delta v over, let's just call that t. Can you solve this anymore? No. Okay, we run into a roadblock. It is solvable if you understand systems of equations. Okay, so we're just going to leave that alone. Actually, I'm going to do one last thing. Is the initial velocity 0, so what is the delta v equal to?
What?
It's VF. So can I do this? Can I replace that with a VF equals minus 9.8?
9.8 wouldn't it
T?
be positive since you
No, it's down. It's
What?
down, right?
You moved it to the right side.
Yeah, you moved it across.
Doesn't the sign?
But that's when you add or subtract. I'm going to divide by, right?
Oh, okay. I know. So I-
And actually, I didn't move the 9.8. I moved the t over and then just flipped the sides is what I did.
So you're mind.
Am I? Okay. Nate, if you want to see it the other way, then it would be minus 9.8 t is equal to delta v. Right?
Yeah, that makes sense. Alright. There we go.
Glad that I unfreaked you. Okay. Is everybody good with this saying VF is equal to minus 9.8 t? Everybody's good with that?
VF equals delta V.
Wait, why?
Because the final velocity is equal to the delta v because
Oh, because
the vi is 0. Very good. Okay. I'm going to make this the last question of the day, because I'm going to blow your mind with this one. So.
What? This is every day.
It doesn't mean we stop working, it just means I stop talking to you. This is going to take a little while too. Okay, so VF equals minus 9.8 T. Okay, what else do we know? Well, we know V bar is equal to VI plus VF over 2. We know that. But I do not know this. I do know that VI is 0. So could I just write that? Yeah?
So then it's a negative 9.8 divided by 2. No,
You're close.
But you're not right.
Okay, I'm going to do one more thing. We also know the formula V bar equals D over T. I do not know the... Oh, I do know the D, don't I? Now, would it be 70.1 or would it be minus 70.1?
Minus is what down?
Minus because it's going down.
Oh, drop. Where you see
Yeah.
drop in it.
Okay, so I've got myself into a bit of a... I'm painting the room here, and I've got myself into a bit of a corner because I've got 3 equations, but I can't solve any of them.
They're useless, man.
No. Don't worry, man. I can solve this. Because is this V bar equal to that V bar? Are they the same thing? Yes,
Yeah,
they are.
sure.
And is this VF the same as that VF?
Sure.
It sure is, right? So here's what I'm going to suggest we do. Let's take this value right here, and I'm going to plug it in there. Can I do that? Because this circled area is equal to V bar, and that says V bar there, right there, right? So I'm going to write, can I do it, should I do it in red? VF over 2 is equal to minus 70.1 over T. Okay, so Gage, one more time. This VF over 2 is equal to? VF over 2 is equal to V bar. And this minus 70.1 over T is also equal to V bar. So this circled thing must be equal to that circled thing, right?
Yep.
So that's what I wrote down here, right? Now, what do you notice about this red equation and this one here with the red box around over here? What's the same about those?
The negative 9.8 T over 2 equal. What is that?
Okay, state that a different way, because you're on the right track.
Yeah.
What's the same about these two? They both contain
VF and T.
VF and T, just like back at the start when I gave you system of equation x plus y equals 6 and x minus y equals 4, right? They both contain x and y. Okay? So I've just shown you a system of equations. There's one equation, there's another one. They both contain VF and T. They're just kind of weird, confusing fraction mumbo-jumbo junk, right? It's okay. What's one of the ways to solve those systems of equations? There's 2. To add them, but the other way is to isolate for x or y and then do what? Substitute. Does that make sense? Isolate and substitute. Anyone ever heard that before? Hope, yeah? Isolate and substitute, right? Okay. Is this already isolated?
No.
It is. I've got VF equals.
Two blocks around it.
It's isolated. No, I mean that the variable VF is isolated. So I'm going to take this minus 9.8 and I'm going to put it where?
Oh,
This is challenging. I get that.
What about the T?
Oh yeah, the T's going too, right? So I'm going to put it in blue. I'll leave it in black. So it's going to be minus 9.8 T over 2, right? This VF is minus 9.8 T over 2 equals minus 70.1 over T.
Oh my god.
It's okay, we're almost done. Hang in there. I realize I'm really pushing the boundaries on a Friday afternoon. I get that. I now have, you're right, Gage, I now have an equation that's only got what in it? I only got T. Can you solve equations that only have one letter in them? Yes. This is a cross-multiply situation.
Oh my gosh.
So minus 9.8 T times this T is T squared is equal to 2 times minus 70.1. And now all of a sudden, oh, well, that doesn't look too bad. T squared is going to be minus 140.2 divided by minus 9.8.
Do you have a question for just starting this meeting?
Well, it's a I get that it's a challenge. It's okay if you don't get these on the first crack. It's really okay. I get T of 3.8 seconds.
It's like one of those questions that like a professor, like a class board would
Yeah.
fill up the whole thing. This is like a lot.
I should get me one of those.
Yeah. Put it around my Can you just write that on a regular old window?
Sure, why not? Let's go back and let's just review that, okay? Let's just kind of summarize that. It's hard. I get that. 100%. I get it. Okay? These problems crop up every once in a while. It's a problem where they don't give you enough information, and you have to leave an equation like this, minus 9.8t, and hope that either it cancels out somewhere down the road, or you can do the system of equation thing. So this is the first one I've shown you. Okay? They pop up. There might be a couple more in grade 11. They pop up in grade 12. Kids go, oh yeah, it's one of those.
Brace yourself.
It's okay. It's okay. So let's see what we did here. I basically wrote down everything I knew, right? I got A equals delta V over delta T. I reduced that down to this. Then I wrote V bar equals VI plus VF over 2, and I reduced that down to this. I reduced this down to this. Then I realized I've got a V bar here and a V bar there, so I set this red circled one equal to that red circled one. I haven't done my attendance, have I? Hello? I do. Can you come in 5 minutes? Okay, thanks. Dane, you're to go to the office. But can you wait till I'm done here? I got you 5 minutes breathing room. Okay? You can sweat it out for 5 more minutes. So I set this circle thing equal to that circle thing is what I did here. And then I realized that this equation and this equation both had VF and T in them. Could I have done this substitution a different way? Absolutely. I could have solved that for T and then put that underneath here, but that would have been like ugly, wouldn't it? Practice tells me I know enough that I've already got this isolated. Putting this in there is going to be okay. So I took this VF equals minus 9.8T and I put it into there, and then I cross multiplied and I solved. And did I answer the question? What was the question? How fast are you going when you reach the bottom? Did I even answer that?
Good job, Mr. Berry.
Do I still know what I'm doing?
Yes.
Yeah, I do. How long does it take to reach the bottom? I got that. So how can I solve for how fast are you going?
Velocity.
Hey, I remember that I said VF is equal to? Can I use that?
Yeah.
Absolutely. Minus 37.1 meters per second. And if you want that in kilometers an hour, multiply by 3.6. Someone's going to have to help me out with that because I don't have that written down. How's the brain? Is it a little sprained?
Yeah, it's a little more.
Only having Mythbusters for now is 3:30.
3:15ish.
Yeah, that's fair. That's fair.
Yeah, let's do that one later.
Ooh. Yeah, 3.6?
Yeah.
No.
Okay. Here's what we'll do for the rest of the day. You've got a problem pack here as well.
Too many of them.
There's lots of them. Okay? I'm not an insane individual. I'm not going to say get those done for the weekend. It's insanity. It's not going to happen. Okay? But I will say this. You should. If I said do 1 to 7 on the front for Monday, would that be reasonable?
No. 1 to 5.
You do realize that some of them are multiple choice.
Hey, that's
I will. Here's the way I'm going to put it. I'm going to give you the answers to 1 to 7 on Monday. You have 2 choices. You can either do nothing and just listen to the answer on Monday. Okay. Or you can try them
Yeah, I tell
Right?
you, that's
Make a valid attempt, right? And you might actually learn something more on Monday to do that.
Make
So
one more example.
I'm gonna now these are not problems. These are theory kind of things. Okay? These are theories. I got a couple more sample problems to show you, and then I'll give you time to work.
So you do some more? Are we? Or no?
Yep, you can do. No, I'm done. I don't want to talk anymore. Okay, I'm gonna give you 10 minutes. I'm gonna put on the video with the penny thing at the end. I added this just today because I read this yesterday that cats over on the right hand side there, the FYI is kind of interesting.
Cats.
Well, see the little ant on the right hand side? Small insects have large surface areas and low weights. They quickly reach terminal velocity of only a few centimeters per second. An ant can fall from a 50-story building and walk away unharmed after hitting the sidewalk. How come?
So late.
It's like the piece of paper that takes forever to land, right? Ants can do that. Now, I read this yesterday. I read it online, said something about cats have this ability to land. Cats have survived free fall problems, or free fall situations 20 times. Does he really have his phone out, Josh? I'm going to ask Lucas what's fair.
Oh, take his phone away. I
Yeah.
don't want him taken away. Take his away.
Let me give you the full meal deal here, Lucas, okay? But I'm going to go.
He's the
I'm
Jackson.